That's the template you'll use for the next project starting Wednesday onward. And then the last one down there is tabbed application, which is also a common paradigm, at least in iOS 6 and prior, where you have got some big icons at the bottom that toggle state among different portions of a program's functionality. So let's do something super simple like empty application. And according to the instructions, this template provides a starting point for any application. It provides just an application delegate and a window. So let's see what this actually gets us. And what we'll do is today is spend some time in particular on what the sample code is that Apple provides, not because it's interesting, but because it's representative of how you might write your own applications. So here we have knowing a number of prompts. I'm going to go ahead and just call this test. My organization name can be whatever I want here. I'll say Harvard University. Company identifier, you just need a probabilistically unique string, really, so that if you push an app to the App Store, it's distinct. We'll go with edu.harvard, which is a common paradigm in the Java world for package names. If we own harvard.edu, presumably no one else in the world is going to use that same prefix for their applications, but it's just a human convention. Class prefix, I'm going to leave blank because it doesn't matter. Devices. For lecture, I'm going to typically choose iPhone, really just so that it fits nicely in the screen so we can see everything. And then there's a few options here. Core data we'll come back to in the future, but it has to do with an abstraction layer for storing data in the equivalent of a database. Use automatic reference counting is that memory management feature I alluded to earlier, having come out a couple of years ago, that makes our lives easier, so we'll leave that on. And then include unit tests. I'll uncheck those for now, but we'll come back to that in time as to how to write tests for your own code. I'm going to go ahead and click Next now. It's asking me where to save it. I'm just going to save it wherever on my desktop for now. For source control, just to keep my directory simple, I'm going to uncheck that for now, but by all means use the built-in Git functionality for doing version control, and we'll defer to any number of online tutorials for how to use that in Xcode itself. Yeah?
Do you have to adapt your code a lot if you choose iPhone and iPad, or is it
Good question. Do you have to adapt your code a lot if you're developing for iPhones and iPads? It really depends on your application and to what extent you want the user interface to just grow to fit or to rearrange itself somewhat. For instance, if you don't implement a different view for the iPad specifically, what Apple does by default is it shows you your iPhone view, but in a tiny subset of the window. And they do give you a 2x button to zoom in. But most every application I've ever seen that just relies on that looks awful. So you would typically want, as a developer, to somehow customize your interface, even if it's just by providing higher resolution graphics for the bigger device, so that it doesn't look like someone just zoomed in on your application. But short answer, it depends. And because of MVC, it's actually relatively easy by not changing the essence of your program, just designing a new view that has similarly named variables, so to speak, to hook into your data. All right, so now I'm going to click Create, and let's start poking around Xcode. And let me go ahead and hide some distractions for just a moment. And here we have, let me move this so that everything's in view on the screen here. Here's everything we have to begin with. I'm going to wave my hand at all of this stuff in the middle, because generally you can dive right in without having to change any of those configuration details. And this is the stuff that's nice to get for free out of the box, rather than opening up something like TextEdit and just starting to write Objective-C code or Vim or Emacs or whatever your preferred text editor is. Xcode just sets up a whole bunch of defaults for you. So let's instead focus our attention on the files that you get for free with an application. But before we do that, let me zoom in on the top left-hand side of the screen. Notice that Xcode is so user-friendly. It's just like iTunes. To run my program, all I do is click play. And if I go and do that, build succeeded. What's happening in the background is my iPhone application is launched in the software-based simulator. And voila, I am now an iPhone programmer. So really, that's all it takes to make an iPhone app. And I'm sure back in the day, I mean, there have been stories, as an aside, where someone made like a Ruby app, was it? Which was just a stupid JPEG of Ruby, the gem, submitted it to the App Store, put a price of like, you maybe recall this, $1,000, and like 4 people actually bought it. And it was really just an image of a glistening gem. So it was that easy for that person to make that application. So this could be you next. So what's actually going on underneath the hood? Well, let's just notice we've got a white background. We still have the status bar at the top. So there's still some built-in functionality there. And if I minimize it by going like that, there indeed is my test application on the desktop of my iPhone. So let's look at what files made that possible uninteresting though this application is. So I'm going to expand these folders. As an aside, they're not necessarily folders in reality. They look like folders, but they're technically groups, which means if you poke around the hard drive of my laptop, you won't necessarily see those same yellow folders. All of the files might actually be in one big folder together. So this is just an illusion for organizing your code like you might in Eclipse or something similar. All right, so it's kind of overwhelming how much stuff there is. So let's start ignoring some of these things quickly. So at the bottom, under products, is test.app. This is just I'm the only one that can see that. So at the bottom of the screen here is test.app. That refers to the program that via that play button I already installed onto my phone. So that's the compiled application. So it's not interesting beyond the fact that it exists. Now let's close that to avoid the distraction. Under frameworks, I see UIKit, Foundation, Core Graphics. Which of those have we seen or mentioned before? So Foundation. So we saw that last week. We saw that earlier in some of our Objective-C code that simply had a reference in the import line to some library that someone else wrote with a whole bunch of functionality, a whole bunch of classes and methods that I don't have to worry about. I can just use them without implementing them myself. We also heard verbally UIKit. So it's inside this library that we're about to get all of the interesting functionality that gives me buttons and text fields and things I can touch and click on the glass of a screen. And Core Graphics we won't use today, but this refers to a two-dimensional graphics library with which we can draw squares and rectangles and more interesting things on the screen. So let's collapse that and ignore. Now we have some pings. So default at 2x, default.ping, default 568h at 2x.ping. Does anyone know what these are? Yeah. Images for? Exactly. So there are some default images that if you read the documentation must be named exactly this, though you could override them if you really wanted. And these are just the images that the user sees as your application boots up. Now for an application like this, we barely even saw them because the thing loaded so fast. But if you have a network-based application, a game that logs into some game server, you might have a couple seconds of latency while the program loads. This is where you'd see the Angry Birds splash screen or something similar like that. So it's just a convention. They're not really interesting for our purposes. Apple gives them to us for free, so let's ignore them hereafter. Test prefix.pch. This is a pre-compiled header, which just means a file that will do some stuff for us that we'll never again, at least for the next several weeks, have to think about. In this case, it has to do with some backwards compatibility, but it's just some additional metadata that Apple uses to bootstrap a program without our having to write this. So I'm also going to ignore that. So we're really whittling this down to the essence. I'm going to skip main.m because that's clearly of interest. Testinfo.plist. This is like a preferences file. A plist is a property list. This is just an XML file underneath the hood. A whole bunch of tags and values and attributes and the like, similar to what you might have seen with Ajax in the world of DOM and HTML5. Xcode is simply reading that XML file and showing it to us in this very pretty fashion with rows and columns, but it's just an XML file underneath the hood. This is a GUI with which to edit it. I'm not going to change any of these things now, but you can kind of infer from the names of the XML elements here what kinds of things you can tweak, what interface orientations you support, up, down, up, left, right, left, those sorts of things can all be configured via point and click by editing this kind of file. But we'll stick with the defaults for now. If we go back to the directory structure over here, info.plist.strings. So we'll come back to this perhaps in the future, but this makes it easy for us to localize our application. What does that mean? Yeah, exactly. Translating it to other languages. So we won't expect you to support more than just English for the staff's choice of projects, but this is where you could define some key value pairs where the keys are like constants that you use in your actual code that represent the words you want your program to actually display. And based on whether the user's device is in Spanish mode or Chinese mode or English mode, a different plist file will be loaded containing those strings and used on the interface for your native speakers. So it's a nice way of factoring out all of the words for a program and putting it, sorry, not in a plist, but into a .strings file, which is essentially just a text file. So that leaves only 3 files of genuine interest. So let's dive into main.m. And it looks, hopefully, a little familiar. Some new stuff, but mostly boilerplate. So let's zoom in. At the top, we have a whole bunch of comments that are outputted automatically by Xcode, depending on how I've configured the program when I first installed it. First line of interest is import. This is apparently giving me access to what kind of functionality? That import line. Sorry? So UIKit, so user interface related stuff. This is allowing me to write a graphics-based application as opposed to the command line stuff you guys did last week with Rob. Import appdelegate.h. Don't know what that is yet, but I remember seeing it among the remaining files, so we'll come back to that in a moment. That's a file that I get to actually interact with. Here's the promised signature for main. We're not going to touch this. Here's auto release pool, and the only thing that's a little different now is that apparently main's sole purpose in life in an iOS application is to return whatever the return value is of a function called UI application main, passing in its argument count, so whatever was typed at the command line, which probably has no significance unless you override some of the default settings in Xcode, passing in argv, same thing, nil, whatever that is. It's essentially null, but with some magic around it. And then lastly, let me scroll to the right. It's a little long, this string, and it's wrapping. NS string from a class, appdelegate class. So let me see if I can avoid the wrapping by shrinking the window a little bit. So here we go. We are returning whatever the return value is of UI application main, passing in these three things, which don't look very noteworthy. The interesting one seems to be this last one. That's effectively passing in a reference to a class named appdelegate. So this one line of code is what's used in the iOS world to hand off control, either briefly or for quite some time, from main to a different class, that class being appdelegate. And it's aptly named in that we are going to delegate control of my application to a guy named appdelegate. So that's the class that I, the programmer, apparently should start writing if it doesn't exist just yet. And as soon as appdelegate is done, apparently main wraps up, my program quits, and returns by default, it's not there explicitly, 0. So this is how we make this leap from main.m to whatever my higher level iOS application is. So we'll never again really need to look at this file. You can't think of any instances in the next few weeks where you'd even want to touch this file. So I'm going to close supporting files altogether and leave us with just 2 files now to glance at. UI application main, it's, sure, C function, yes. Happens to be capitalized, but it's a function, not a method. All right, so when looking at files for the first time, I would generally suggest to start with the .h file, in part because it's simpler, usually shorter, and also because it's often more descriptive. So let's start there, and indeed it is short. Let's see what's going on. A whole bunch of comments at top. I'm importing the UI kit again so that apparently my class can have access to its functionality. And now we see a similar construct to what you saw with Rob last week, and we recapped a bit ago, at interface, appdelegate, UI responder, open bracket, UI application delegate, close bracket. So let's start translating this into slightly less technical English. What does that one line of code do? Yeah. OK, it says what's a child of UI responder? OK, it says that the class called appdelegate is a child of UI responder. Good. And what else? And it adheres to the UI application delegate, and I'll scroll to the right to confirm, protocol. So what does that mean? It means not only does it behave much like a UI responder object does. I have no idea what that is, but it sounds like something Apple wrote because it starts with UI, part of UI kit. And UI application delegate is apparently a set of methods that Apple says I have to implement if I implement that protocol. Now this, for the most part, is copy-paste. We won't be so presumptuous as to change these defaults. We'll typically isolate the code that we write else to other files or subsets thereof or to new files of our own. But let's focus on one other detail. Inside of this class definition for the appdelegate class, there's also a property. What was a property? Yeah. Yeah, exactly. It allowed us to synthesize, so to speak, a getter and a setter for ourselves automatically. In other words, to provide programmatic access, functional access to what's typically an individual instance variable. And what's useful about this is that you can specify some attributes for those setters and getters. And we'll see this in more detail before long, but non-atomic just means, hey, Xcode, when you generate that getter and setter for the property called window, don't